Welcome to Analytical Technology Center. This is our micro GC. Look like having two TCD detectors and three sample ports available here. The sample ports, sample 1 and sample 2 and sample 3. These are the sample ports. And using helium and argon carrier gases. This is the power switch we have here, and this is our software window. And we have few options like view setup. In this we have to select the task, run sequence, single run, multiple analysis, and calibration update. But for the sequence run, we have to select this single run, multi run, and for the calibration, we have to select this calibration and update. And this is the method. Which method we are going to use? You have to select it. If we are going to use test method. If you are going to use multiple test method, this one. And which sample port you are going to connect. If S1 or S2 or S2 S3. If it is multiple run, so how many multiple runs we have to do, and that analysis period of run here we have to add. And then we can start from here. Connect the sample in the S1 port here like this, and after you can start from here. Under one status, instrument status, we can check it here. This is the instrument status. The flow of carrier gas will show here, and is the pressure 1 and pressure 2. Pressure 1 it is argon, and pressure 2 it is helium. We set it here for 405 kPa. So this is the instrument status it will show. Now there is no sample is running, so that's why it is in blue, disabled. If sample runs, it shows like green. If the sample is running, it will show like this. And sample flow shows here how much flow it is going out. Now there is no sample connected, that's why it is not showing. And there are two channels here and two TCD detectors. This is the channel 1 status. Whatever the method we have set it will show the injector temperature, column temperature, carrier, and TCDs. And this is channel 4. This window is live window. Whenever the sample live run, it will show the peak here. This is the live sample. The good thing of this micro GC is the sample time, running time is only 60 seconds, means 1 minute. Under 1 minute we can complete the run. And this is the result window. View setup. So whatever the run completes here, we can see. So this is the carbon dioxide and ethane, ethylene, and here hydrogen, oxygen, nitrogen, methane, and carbon monoxide. There are two channels. In the channel 1 we do this here, and channel 2, channel 4 this will come. Here the dates. For the previous things we can change the dates and we can check it from here. And runs, now we did this first run, second run. By selecting here we can change it. And for the reports, You right click here and create a report, name the thing, and wherever you can save it directly copies to PDF file. Now we are going to see the method setup. For example, method editor. So here we can create new method, or we can edit existing method or something. Now we are going to create a new method like demo. Here we have a temperatures. Here is the injected temperature for channel 1, 120, and the inject column temperature 70. This is we are going to use, and carrier gas 160 kPa for channel 1. Like that is 70 here, or 100 to this. Like this we can create as per the sample and as per your method. And we have a sample pumps here. For this is, if it is 0, it is for the cylinders and the pressure samples. We don't have to pour on the sample pumps. For the bladers or less pressure sample supply, we have to enable the pumps. For enabling, 1, and here also 1. And 60 seconds run. As per the sample, we have to set up these things. And next, it's okay. And next, this is the pilot run. Pilot run means first we have to run the gases here, and for the identification purpose, first we have to connect the sample gas to that and start the sample, and we can get this is the channel 1 and channel 2. First we have to run the sample, and for we have to get the peaks like this, whatever the calibration gas or whatever you are going to do. And do next. For the integration purpose, we have to use this. It will automatically integrate, and this is the identification of each single gas. This is the carbon dioxide, and this is ethyl and ethane, and in channel 4 methane and carbon monoxide. This we have to do for the ones while creating the method. It saves it. If you want to change the RTC, the peak is getting low. So if any deviation, you can change by manually here. That's all peaks. You can check it. What are the deviation, you can change from here. Next, this is the calibration window. We can do 5, 6, 7 point calibration also. So I did 5 point calibration. This is the gas calibration 1, gas 2, and gas 3, and gas 4, and gas 5. If you want to add, right click here and add the standard, means it will come another one. So like this you have to add, like this you have to add. For the same for the gas, for this calibration gas, what's the gas present in the cylinder. So cylinder, and as per the percentage you have to mention here like this. This you can get from here. This is the gas present in the calibration gas, and this is the percentage also of this. So the same thing, I taken this as a gas one, and I taken here, and I mention everything. So and we have to mention every individual. So the same here. So we have to select here linear to zero and standard recordings. And for the standard, here we have to select hydrogen, oxygen, nitrogen, methane as per this. So, the same for channel 1 also. After doing that, here it will show whatever the gases we have taken and the percentage of gases present. Next, and save. I am closing it because I will change. Now we are going to check or do the calibration. So how we do the calibration. So first we have to connect the cylinder calibration cylinder to the GC, and after that you have to select calibration and update option. So and you have to select the method which is going to use. Before doing calibration, you have to create the method and select it. And here in the method, how many gas points you have selected, it will show here. Means if it is 4 points, 2 points, 3 points, as per your method or as per your sample, you can do it. Now if you want if you want to go into gas 1 point, so you have to select gas 1 point, and the sample stream you have to select from here, and multiple times, minimum 3 times you do, or maximum 10-15 times also you can do. So on the run, and after that you start. After completing this, after completion, it will ask here is the percentage, it is the gases mentioned, this is the percentages, this is the response, and everything it will show here. If everything is good, then it will ask keep. You keep, and if you keep this, it will keep on update to the calibration. If you don't want, you can revert it. The calibration will cancel. The same way, one after one, for gas 2, you connect the gas there and to the sample and run. So gas 3, same, the cylinder calibration cylinder, you have to connect to this one, and the same things you have to continue. After everything, after completion of everything, you have to come to the view selector, and for the calibration view, you have to right click here and open calibrator. So for the channel 1, we have carbon dioxide, and see we did 3 calibration points, and the R-square value 2.9. For the same ethylene, we selected 2 points, and this is the thing, ethane. For the hydrogen and oxygen, we select taken 4 points from 0. Nitrogen we taken 6 points, and methane and carbon monoxide. This is the calibration, linear calibration things. How many? It's up to you how many points you have to do of your of your sample range. As per the calibration, your result will come. See, now this has nitrogen has in having 57, so you can check it 56. You can check it nitrogen here 56 point in the point it is showing. Hydrogen it is very low, so then it is showing here. And oxygen 12 in the calibration it is showing 12. And 57.4, and these are the low levels. So this also you can find here. Carbon dioxide here. For conditioning the GC, we have to go to method, editor method, existing method, and ideal method. Next, conditioning means the instrument is on off power off for 3-4 days or 1 week, so we have to do, otherwise the separation of the peaks is not getting good. Then we have to do the conditioning means conditioning to the column. For the column we have to give 150 degree temperature like this. There are two channels and two columns, 150 for channel 1 and 150 for 2. Other things no need to do. Next, and save. For the same way, after conditioning, if you want to cool, the same thing we have to select here. Okay, select ideal method. Next, keep 70 in the column 1, 7 channel 1, and keep 70 in the channel 4. This is the cooling method. And this for the same next and save.